Hello everyone, I hope you are doing well. So in this video we are going to discuss the solutions for the problems A, B and C for Codeforces route 830 which was rated for division 2. So let us quickly start with the first problem. The first problem states that we have been given a permutation of numbers of length n, and in one operation what we can do is we can choose any two indices I and j and swap the numbers present in those locations, right? Now our task is to make the sum of the first k numbers as small as possible. So you can see the sum of p1 plus p2 plus p3 and so on up to pk should be as small as possible. So essentially the sum of the first k numbers should be as small as possible. Now what from this what we know is it is a permutation of numbers, right? So it should be it should be of this form, and to make the sum of the first k numbers as small as possible, those k numbers should be 1 2 3 and so on up to k. This is a thing I know for sure, right? So let me explain you the whole idea behind this question. For example, if I have a permutation 5 4 3 2 1, right, and I need to make the sum of the first three positions as small as possible. So to make the sum as small as possible, definitely I would choose 1 2 3, right? I would choose these three numbers. The order of these three numbers does not matter, it's just that these three numbers should be present at the first three positions. It can also be 3 to 1, it doesn't matter, right? So now what I can do is I can swap these numbers. So like for example 2 is present here, I can swap it with 4 and this would be counted as one operation. Now I need to take 1 2 and 3 or the first k numbers to the first k positions. Now what I can simply do is I can start a loop from k plus 1th position till n and check whether this number is a number from 1 to k. I can it would be just a simple condition that whether v of I is greater than equal to 0 and v of I is less than equal to k. If this is true, then you have to increment 1 in count, then count will be count plus 1, right? So this is the whole idea behind this question. While I was doing the question during the contest, I didn't read this statement very properly that it is a permutation of n numbers, and I implemented it for any numbers, right? So I implemented it in a little different way. For example, what I did was I copied that vector into another vector. So this is another approach for the same question. This approach would definitely work because this is a permutation of n numbers. But if this wasn't a permutation of the n numbers, then the approach that I have used will work, and which what I did was I just sorted this array. So I will get the first three numbers, right? I will get the first three numbers, which are the first three numbers, and then what I did was I just checked whether these positions contained either of these three numbers. I incremented the count. So this is the second method to implement this particular question. What I did was, you can see, I just copied the vector and I sorted it, and in the next step I pushed back the first k numbers from this copied vector which was sorted into another vector, and from the kth position till the nth position I just simply searched whether this vi is present in the third vector in which I have stored the first kth elements, right? This is also a way to do this question. And the first method which I said, because we already know that 1 2 and 3 would be the smallest three numbers of the given permutation, right? So both of the methods would work in this particular question. Now moving on to the second one. The second question is vocal permutation, and it states that we have been given a positive integer n. Now we have to find a permutation of length n such that LCM of 1 comma p1 plus LCM of 2 comma p2 up to LCM of n comma pn is as large as possible. So to make this LCM sum of LCM large, obviously individual LCM should also be as large as possible, right? So if you talk about the properties, LCM of a comma b, to make this thing as large as possible, we know for a fact that GCD of a comma b should be 1. So this is one idea that I have in mind. Why this is true? Because LCM into GCD is equals to A into B, right? So to make this particular thing large, I have to make this GCD as small as possible. So LCM will be largest when GCD of A comma B will be 1. Now there are actually multiple ways to make the GCD as small, GCD equal to 1. For example, there is a permutation like this: 1, 2, 3, 4, 5. So to make the GCD 1, I can write it as 5. Uh, I can write it as 2, 3, 4, 5, 1. So this can be a permutation where the GCD of each element is 1, but this might not be the best case. So this might not be the best case in every scenario. Why? I'll show you one more permutation in which the GCD is 1 as well as the sum is the largest possible. So for example, if we have 1, 2, 3, 4, what I can do is I can just swap the adjacent numbers. I can write 2 1 here and I can write 4 3 here. So in this case, if you check, GCD of 2 1 is 1, GCD of 1 2 is 1, GCD of 4 3 is 1, and GCD of 3 4 is 1. So this is this will also lead to large LCM, and this will yield the largest sum of uh, all the given permutations. There is one more case when the value of n is odd, and in this case what you can do is you can just simply write 1 here and then swap again on the rest of the things, right? On the rest of the numbers you do the swapping, and on the first place you write 1. So these are the two cases. This case is for even, when n is even, and this case is when n is odd. So these are the two cases that you have to consider. These are the only permutations that will yield the largest sum. Why this is true? This is just because of observation thing, and there's no valid proof behind it. It's just you have to observe that these are the permutations that will yield the largest result, right? So moving on to the next problem, the third question. So this question was sort 0, and it states that you are given an array of n positive integers. Now in one operation, what I can do is choose any integer x, and for all indexes in which x is present, I can assign that place as 0. I can replace x by 0 at all positions of x. Now I have to find the minimum number of operations required to make the array non-decreasing order, in non-decreasing order. Like, so the two important things are the array should be non-decreasing, and if I choose any integer x to replace, then I'll have to replace all the positions of at which x there is a value x, and I have to replace it with 0, right? I have to replace all the positions. So how to approach this question, I'll tell you. For example, let us just consider 4 3, this would be the case, and let us say there is 2, and here is 2, here is 4, no, I can say here is 1, and here is 1. So let me leave it like this. So we can start traversing from the back, and we check this number. Now this number is smaller than 2, so there is no problem. And this now we go here, 1 is equal to 1, so there is again no problem. But when we get to this position, I see that there is 3 present which is greater than 1, so it destroys our goal to make it non-decreasing, right? So this particular element should be made 0. This is for fact, right? This particular thing I know, that this particular element or this particular index where the current element is greater than the next element, I should make it 0. But if I make this 0, I will have to make all of these 0, right? This is one more thing for sure, because if you read the question carefully, then AI is from 1 to n, right? If I make this particular thing 0, all these numbers which are present in these positions, right, they would be greater than 1, and I cannot leave them like this. I have to make them 0 as well, right? But there is one more consequence of this thing. The problem is when I make this 2 0, then 2 is also present here, right? And then all these numbers would also have to be 0, because if 0 is present here, 1 cannot be present here, right? And 1 cannot be present here similarly. Also, if for example if there was a 3 here, and if there was a 3 here, let me take another bigger number, let me take 5. So the 5 can remain as it is, because I have not deleted 5 anywhere, right? When I delete this 2 and make it 0, I will have to make this 2 here, and 5 can remain as it is. There will be no changes to 5. So the first observation was, as soon as I hit a number where vi is greater than vi plus 1, I will have to make this particular index 0. Now all the numbers which are present from 0 to I, for example there is the index 0 to I, all these numbers would also have to be 0 again. Now if this number is present here, this should also be 0, and the corresponding number should also be 0. So what can I do is, I can take all these numbers and find the number which was the last among them. For example, if 4 was also present here, then I will have to make 4 0, this particular number 0 and all these 0. But if 4 was present here, I will have to make 4 0 and all these numbers 0, right? So I just have to find the position of the last element which was deleted among these. For example, 2, 4 or 3 was deleted, I have to find the position of the last element among these. For example, if 2 was present as last, then the index would be 2. If 4 was present at the last, then the index would be 4. If 3 was present at the last, then the index would be 3. I'll have to find the maximum of these, and from there I'll have to make all these 0 till 3. Right, understood? So I have to make these 0, and among the last I'll have to take it, and from there I'll have to make all these numbers 0 till this number 3. So how do I implement it? There is I've already told you this thing, that this observation, that ai is present between 1 to n. So what I can do is, so this was the code for the second question. And this was pretty simple actually, so I didn't show it. But if you still want to see, then like for odd numbers it is 1. First we print 1 and then incremented by 1, so that it starts from 2 for odd, for n odd. And for other numbers we just swap the elements and print it. So this code was very simple. We need not to discuss it. For the C question, what I did was I created an array which stored the last position of every element. So this element I should range from 1 to n. So, and the value of n is 10 to the power 5. So we can easily make this array. And in this loop, what I do is I store the last position of the element of every element present in the vector v, or the given input, right? Now what I do is I maintain a set of the elements which were removed. So why I am maintaining the set? Because I need to find, because if I remove one element of 2, then all the other elements are removed, right? I need not to store it differently. So this will help me to store the unique elements removed. Again, I do the same thing. If vi is greater than vi plus 1, what I do is I save the index and I insert it in the removed set, and I store the last index as max is equals to v of last of v of I. Now I remove all the elements from 0 till the index which I stored here, right? I remove all those elements and I store max is equals to maximum of max comma last of v of I. So I'm just calculating the last index which I have to save, right? Then again from index plus 1, I go till max plus 1. Max plus 1 means including the index max, and I insert it in the removed set, and then finally I print the size of the set which will give me the required result. So these were the solutions for the first three questions. I hope you liked it, and that's it for today. Thank you.